Okay, welcome everybody. This is a quick lecture on periodicity. A lot of this has been covered in the basics of the periodic table, but I think it's really important to go over some of it. This is not just a fancy name. They don't just call it the periodic table of elements for a reason. And the shape of the periodic table, it's not just that shape for no good reason. It has a purpose. And actually, sorry to burst your bubble, this is what you're used to looking at for the periodic table. And this is the actual shape of the periodic table. Okay. Now, this doesn't really do us much good to fit this into a textbook or on a wall in a classroom. So what we do is we take out the bottom couple rows, we shove them on the bottom, we move the periodic table closer together, and there we get a nice shape that fits into our textbook. Now, looking at this periodic table of elements, we've talked about Mendeleev. We've talked about how we organize it. What we're going to look at is periodicity, what it is, how it works. The word period, okay, I've used it in multiple ways, okay. For sake of using the notes here, you have periods in a hockey match, you have a period at the end of the sentence, you have periodicals in the library, and you even have the female menstrual cycle, which is a period. All that is, it's a repeating interval, regular interval of time, okay. 20 minutes for a hockey period. A period at the end of a sentence. Every 28 days you have your period, your menstrual cycle, and all these fall into line of why it's called the periodic table of elements. Now, let's look at this and understand that there's a simpler way to look at what Mendeleev had to do, and let's take a look at that now. Okay, when Mendeleev started out, he had just a whole bunch of elements. He had to figure a way to be able to study these and organize them. I think we could do that pretty quick, actually. Okay, here we are. We have them arranged. Tallest to shortest. We did our best school picture example here. However, this A is really long and really hard to study. And B, I think there's even more ways that we can arrange and organize these. So let's do that now. Okay, so we, or Mendeleev, went from a jumbled mess to putting me in a line from tallest to shortest, to now he took the tallest ones and organized them into Roy G. Biv. Okay, I apologize for our colorblind members of class. That's red, orange, yellow, green, blue, purple. And then our next set, red, orange, yellow, green, blue, purple. And then red, orange, yellow, green, blue, purple. But we still have this issue of this giant long line that's really hard to study. So let's put these into periods. I think if we stop at that tall purple one right there and restart with a new period, we might see something that's pretty unique. Let's try that. Nice and organized. So we arranged them, tallest to shortest. Then we arranged them by color. Then we broke them into periods. We stopped at the last tall triangle. We started a new period at the second tallest triangle. We went through that period, we reset, and went to the shortest ones. We have a problem. There's a big open gap in the middle. Now, we're going to get to that when we talk about predicting periodic trends. However, Mendeleev had this problem. He had a lot of issues with his periodic table of big gaps that he didn't have. He didn't have all the elements. What he did was he was able to predict them. So we're going to talk about that in the next section. All right, so Mendeleev. He came around in 1869, and all he did was he took the periodic, the elements that they already had, he wrote them down on note cards, good old note cards, and he started to find a pattern, okay? And he arranged them all, and he put them into what he thought was his original table here. Now, you'll notice there are big gaps. There were big gaps when we were playing with the magnetiles. However, he was able to predict what was going to go there based on the periodicity of properties, okay, those repeating patterns that he had found. There he is. It's my man, Mendeleev. Okay. People didn't believe him at first until he predicted germanium. Okay, He had stated that if you find and when you find this element, here's the properties of that element. They found it. These were the actual properties. Pretty impressive stuff. Okay, he did that a couple other times. Scandium, gallium, he was able to predict those. And after that, people are pretty convinced that this was the correct way to do it. However, what he did, how he organized it, I should say, was he organized them by mass. Okay, he organized his periodic table by mass. Now, that is really the only mistake he made. Mendeleev did 99% of the work. Then, in 1913, Henry Moseley came along. Okay, he had some new scientific methods that he could use. He took all of the work that Mendeleev had done, organizing the periodic table by atomic mass, and all he did was use the atomic number. So, in other words, he used the number of protons. Okay, and that's what he went off of to make his periodic table, because there are a couple examples in the periodic table, and if I zoom in here, most of the elements on the periodic table, if I look, I go from 114 to 118 to 121. I'm increasing. And I go 118, 121, 127, 126, 131. So in this area right here, I actually decrease my atomic mass. So, and just a reminder, this is Moseley's periodic table. This is Moseley's periodic table because this is arranged by atomic number, by protons. So there are a couple areas in which the atomic masses break the periodic trend. They go up as opposed to going down, or vice versa. They usually go up, they went down. But again, to repeat, Mendeleev did the vast majority of the work. Mendeleev came up with this based on the mass. And then all Moseley did was come along and say, oh, if I do it by atomic number, it fixes all of those little glitches that are in there. Pretty good work by Mendeleev. Moseley did a really nice job finalizing it, but the father of the periodic table is Mendeleev because he did 90.